Hello and welcome, my dear students and my viewers, to my channel Mathematics Made Easy. This is Ms. Ruchika welcoming you to today's session for my grade 10 elite students. This is the lesson 7-6, solving systems of equations using Kramer's rule. Today we are on part 4, which is the last part of this series, and our learning objective for today would be to solve a 3x3 system of linear equations by using Kramer's rule. Today's video is a must-watch video, very important, especially for all the grade 10 students. One exam question is surely going to come along one from this topic. So let's dive into this important video. Make sure you watch it towards the end so that you have a good understanding of using Kramer's rule for solving 3x3 system of linear equations. Okay, so now we are going to do Kramer's rule for system of three equation. So we have here three unknowns x, y, z whose value we need to find, and there are given three system of equations. So this is the first, the second and the third equation. That's why it's called a 3x3. So first thing that you'll do, just like the Kramer's rule for the two equations in two variables, that was my last video. I'll put the link in description box. Make sure you watch that video before this one for better understanding. Okay, so we find here the coefficient matrix, which is denoted by capital C, and it is the coefficient. So we take in the first column the coefficient of x, so A, F, J. Second column the coefficient of y, so B, G, K. These are just numbers, positive, negative, 0, integers, and then C, H, L. So that is your coefficient matrix. So this system of equations, three equations in three variables x, y, z, will have a unique solution, or the solution will exist if the determinant is 0. So the condition that you will check is determinant of C, this matrix, is not equal to 0. If it is 0, we cannot find the solution. It might be no solution or it might be infinite. So for unique solution, this condition is the first thing you will check. Next comes your values of x, y, z. The formula for Kramer's rule states that the denominator is equal, which is the determinant of C. For numerator, you will look at the numbers in the determinant. So for that, you will have a look at the system equations given. So we'll apply the same trick like we applied in the last video for Kramer's rule for 2x2 system. So we are going to cover the coefficient of x. Now here I'm going to use a highlighter since I can't show my finger to cover. So we are going to cover these coefficients of x and we are going to take the remaining ones. So remaining ones, we start from the right. So M, N, P, that's the first column that comes. Then the next one is the coefficient of y, so BGK, BGK, and next is the coefficient of Z, CHL. So we follow that order to write the determinant. Whatever is the value of the determinant will be divided by the value of determinant C to get your value of x. Next comes y. So we do the similar thing for y. We cover the coefficients of y. So b, g and k will not come here. We start from the left here. So a, f, j, that's the order, a, f, j. Then we go to the right and we take M and P. So the order is different here. The mistake that you might do, you might take A, F, J and then C, H, K. So no, that is not here true. So first you write the right elements and then you come to coefficient of Z. So this is how your Y works. Last is Z. So for Z you cover the coefficients of Z and you write the other coefficients. So A, F, J first for X, then for Y, and finally the right side, which is M and P. So as you see, for Y it is a little tricky, the order is switched actually, but for others it is quite easy. So you'll have to learn this Kramer's rule formula so that you are able to apply it for solving question. Very important, and in your exam sure short question will come. So let's see what kind of question to expect in your exam. So first let me explain to you from a solved problem, then we'll solve a problem together. So here you have to solve the system of three equations, 1, 2, 3, using Kramer's rule. So first step is to find the determinant of C to check whether this is non-zero or not. So I'm going to write the determinant with the coefficients along with the sign. So the determinant is 4, 3, 7, then 5, minus 2, minus 6, minus 6, 7, and minus 8. Now, I have already made a video for all my students how to expand this determinant, how to find its value along the first row. So that trick you may use here. So you remove the row, remove the column, take this matrix, and then for the middle element the sign is changed or flipped. So remove this row, remove this column, you are left with these four. 3, 7, 7 minus 8, and last element minus 6 times, remove the row, remove the column. So 3, 7, negative 2, negative 6. So simplify this, and on simplification this value comes out to be 621, which is non-zero. So we say unique solution exists. So there is a value of x, y, z that you can find. X, y, and z are denoted by these three formulas. Just plug in the value. For x, you will get it as 5. For y, after calculation, you will get it as negative 2. And for z, you will get it as 4. So the solution will be the set of 5, negative 2, and 4. X, y, and z in that order. Further, you may check your solution, the one that you get, by substituting in the three equations. If the left hand side is equal to right hand side after putting the solution you have got, that means your solution is correct. If not, there is some mistake, you need to correct that. Also, now let's solve some questions together. So this I've taken from your math book, from the guided practice. This is what we'll do together, and this one you may try later as your homework. I've also provided here final answers so that you can check your solution. And let's now solve 5a in detail step by step using Kramer's rule. Okay, so let's solve 5a question using Kramer's rule. We are going to use 3 cross 3 matrix as we defined. So step 1 would be to write the coefficient matrix. So I'm going to take all the coefficients of x, y, and z here to write it. So the first column is coefficient of x, followed by second column coefficient of y, and last but not the least coefficient of z. So this is your coefficient matrix. Now we'll find its determinant. So we'll convert it into this form. And you already know from my previous videos how to expand 3 cross 3 determinant along the first row R1. So first, second, third, this element. For the second one, there's a negative sign. So I'm applying my trick. 3, negative 5, and 2. Okay, now when we take this element, I remove the row, remove the column, so I have only this matrix, the second order determinant. Remove the row, remove the column, these four elements. Remove the row, remove the column, these elements. Follow the diagonal rule. And you can simplify as 3 times negative 7 plus 20 minus 5 times 28 plus 25 plus 2 times negative 16 negative 15. So you can use your calculator, do this calculation, and it reduces to 3, 2, 4. So it is non-zero, determinant is non-zero, so Kramer's rule is defined, and our variable for x would be defined by, so you remove the x coefficients, just take y, then you take the constants, and then you take z. So you follow that order. So I'm first writing for, I have covered x, so first I'm going to write for the numbers. So 7, negative 19, negative 15, the right side you write first, then x is already covered, you come to y, and then finally z. You can evaluate the determinant using the same technique, and you divide it by the value of determinant of C 3 to 4. Then you write y, again the denominator is same, then you write z, again denominator is same. So for y, you first cover y and you start writing from x. So 3, negative 4, 5. Then you write the numbers on the right. So y is a tricky one. Make sure you write the order well. And after that, the last one, which is z to negative 5, negative 7. Last but not the least, for z, z is the most easiest. You first write coefficient of x, y, and then the numbers. So 3, negative 4, 5, 5, 3, 4, and negative 7, negative 19, negative 15. So you can evaluate the determinant, and the value of x will come out to be 23 by 22. The value of y will come out to be 57 over 22. And last but not the least, z will come out to be 31 by 22. So that completes 5A question. Please try 5B yourself until you become more confident with Kramer's rule. Discuss one question. This is a very simple mistake that some of you might do, so I don't want you to do this error. That's why I'm taking this question specifically. Here you see the three equations are given, 1, 2, and 3. You just have to solve using Kramer's rule only for x in this question, okay? And here, while you are finding the determinant of the coefficient matrix, here it is defined as capital D, some of you might do a mistake. What is that common mistake? If you observe the equation x, y, z, there are three variables. For the first two equations, their coefficients are well defined. However, for the last equation, you observe there is no coefficient of 0. So it is 0 times x. However, because this 3y is written below the x column, some of you might take 3 as the coefficient of x or 5 as the coefficient of y, which is wrong. So the last equation 3 is actually 0 times x plus 3 times y minus 5 times z. So just to highlight that error, I wanted to show this, and let's now solve this question. Okay, so now let's write the coefficient matrix. So this D is equal to, first we write coefficient of x, so 2, 1 and 0 for the third one. Then we write for y, negative 5, negative 4, and for the third one y is here, so 3. Then for z, 2, 2 and minus 5. Now we need to find determinant of D, or the determinant of 2, 1, 0, negative 5, negative 4, 3, 2, 2, negative 5. So use my shortcut trick. You expand it along the first row, so 2 times, remove the row, remove the column, negative 4, 3, 2, negative 5. Change the sign of the middle term, so it becomes plus 5. Remove the row, remove the column, 1, 0, 2, negative 5, plus 2 times, remove the row, remove the column, 1, 0, negative 4, 3. So let's simplify. 2 times, now apply the diagonal rule. First you apply primary diagonal, then you subtract product of secondary diagonal. So this is 20 minus 6 plus 5 times negative 5. This is already 0. This one is already 0. So these two will vanish. Plus 2 times 3. Okay, so this is 2 times 14 minus 25 plus 6. So when you simplify, this is 28 minus 25 plus 6, 9. Okay, so the determinant here, the boxes will be 9. Numbers already I have written here. Now we need to find x. So for x, what do? We just write the constant. So 1, negative 4, 0, and then we write the coefficient of y, so negative 5, negative 4, negative 5. Then we write for z, so 2, 2 and negative 5. So here we have to write 3. Yeah. Okay, so now you just simplify. D is already there. D is 9. So this is equal to 1 times -4, 3 to 5, plus 5 times, remove the row, remove the column, -4, 0 to 5, plus 2 times, remove the row, remove the column, this one. Okay, so now you simplify this and divide by 9. This calculation will come out to be -110 over 9. So that's your value of x. Now in this question, only x was asked, so we just find x. Similarly, you may find y and z using Kramer's rule. So that completes today's video. I hope you have understood Kramer's rule. It's a little long. Try to practice more and more questions till you become more comfortable. So that brings us to the end of today's session. That was all for today's video. Thank you for watching the video. Make sure you give it a thumbs up if you liked it and found it useful. Do put your comments and suggestions in the comment section to let me know which more videos you want from what different topics for grade 10. Until then, this is Ms. Ruchika signing off from today's session. See you in my next video. Bye bye.